So we did talk about how to derive a function using the first principle and the basic power rule, right? The basic power rule. So now, what if we have a function given as of course, what if we have a function which is equal to a function times another function? Okay, so remember when we did the derivative, using the power rule, we only had a function equal to some function, right, which let's say it's x squared, right? So here we could derive easy, right? But now, what if we have some function? Let's say, what if we're multiplying two functions in that case? So what if I have, for instance, well, 2x cubed plus 3x squared times x squared minus x, right? Now what happens now in this case? Well, this is what we call the product rule, right? So the word product is basically the same as multiplication, right? So you will hear that this many times in physics. So product means multiplication, right? So how can we derive this function? How can it derive this function? Well, one could say, well, we could use the FOIL method, rather open up the bracket first and then add the like terms, and then after we could differentiate after adding the like terms. Well, that seems like a whole lot of process, right? So the product rule now comes in to solve that whole process, to make it easier for us to differentiate two functions that multiply each other, right? So the product rule now will help us to differentiate this in simple terms, right? So remember, the mathematicians, we do not want to make things complicated for ourselves, right? We take the easiest things. We use the easiest things, or rather the easiest method, although the hardest method will make us look like geniuses, but we want to take the easiest method as possible, right, to consume time, right? Okay, so now we will look at how to differentiate the two functions that multiply each other using the product rule. Okay, so remember, with the product rule is given as two functions that multiply each other. So the formula to derive using product rule is given as f prime x is equal to, well, you will say that derivative of the first function or the second function doesn't matter. So I could say, well, the derivative of gx times this function here, hx, then I'll say plus and then if I started with gx, so in this case now I'll have to start with h, so meaning I'll say, well, the derivative of hx times now this function here, which is gx, right? So this formula here is easy to remember, because basically you find the derivative of this times that, derivative of this times that, right? Doesn't matter with which one you start, because here we have a positive, so it doesn't matter with which derivative you start with. As long as you derive one function, you multiply it with another, derive another function and multiply it with another one. So I won't like show you how this this formula comes from, right? Because we are not interested in that. The only interest is to know how to use it, right? So, but if you are curious, basically this formula here comes from the first principle. So everything comes from the definition of or rather the first principle, right? Whatever we do, whatever rule that we do when it comes to derivative, it comes from the first principle. So this function here comes from the first principle. Okay, so now let us, okay, now that you know this formula here, let me just put it in somewhere there. Okay, let's take this formula. Oh my goodness. Okay, let's put it there. Okay, now let us look at an example. We will look at this formula here as our reference. Well, let's say we are given fx is equal to, let's say what we had 2x cubed plus 3x squared times x squared minus x, right? You can go ahead and pause the video, try this on your own. So the first thing is to find, well, f prime x. Well, this function here, I'll say this function here is my g of x, right? And then this part here is my what? Is my h of x, right? It's the function hx, right? So you're gonna apply the same this formula here. This is given as, well, the derivative of gx times hx plus the derivative of hx times g of x. Okay, so remember to use the bracket. So you're gonna find the derivative of g, which is this part here. So using the power rule, we can find the derivative of that, which will give us 6x squared plus 6x, and then times this function here, which is x squared minus x, and then plus the derivative of this function here, which is 2x minus 1, and then times this function, which is 2x cubed plus 3x squared, right? So we didn't have to use FOIL method to expand, or rather to remove the bracket so that we could differentiate, but instead we could differentiate from the get-go, right? So we could just differentiate using this formula here. Okay, I hope that makes sense. Let's look at some more examples so that you guys could could grasp this or rather would understand this formula. So let's say fx is equal to the square root of x plus 3x multiplied by x squared plus x, right? Go ahead and try this on your own, right? So here again you can see that you do have this function here, which is gx, right? Which is, bring this up, so this is my gx. I hope you could see this. So this is my gx, and this part here will be my hx, right? So we're basically multiplying two functions in that case. You can see there, multiplying these two functions. Therefore our formula is given as f prime x is equal to g prime x times hx plus h prime x times gx, right? So here again we could derive this function here inside. The derivative of that will give us a half x raised to the power negative a half. The derivative of that will give us negative, or rather positive 3, times this function here, which is x squared plus x plus what do you call this, oh no, plus, close the bracket, and then you say plus the derivative of this function here, which in that case will be 2x plus 1, and then times this part here, which is the square root of x plus 3x, right? So now remember, we said we do not want to deal with negative powers, so I'm going to bring this down, and hence I'll have a half square root of x plus 3 times x squared plus x plus 2x plus 1 times the square root of x plus 3x, right? So this is how we could apply the product rule. Whenever you're basically given two functions that multiply each other, then you could use the product rule, right? So again, one could have expanded the bracket. You could have expanded the bracket and then differentiate everything and then add up like terms. But again, if you like things made easier, then you could use this formula here. It is very easy to remember, and yeah, right? So now you could expand, or rather you could use the foreign method after that, but yeah, you don't have to basically use the foreign method because this is a differentiation, right? This is f prime x, unless if they say, well, simplify further. Therefore you have to now open up the bracket and then add the like terms. Okay, yeah, but we could do that. Let's try and expand this bracket and then let us see what will happen. So you're gonna times that with that, and then it will give us x squared divided by 2 root x, right? And then plus that times that will give us x divided by 2 root x. Then that times that will give us positive 3x squared. That times that will give us positive 3x, and then plus that times that will give us 2x square root of x. That times that will give us positive 6x squared. That times that will give us square root x, and then plus 3x, right? And plus 3x. So now I can add up the like terms, right? Can add up the like terms. So here, what do I have here, right? So I'll have a half, and then x, basically 2 minus a half is the same as 2, rather 4 over 2 minus a half, which is 3 over 2. So here I could have 3 over 2 plus, here similarly will be 1 minus a half, which is 2 over 2, which is the same as 2, which is a half. In that case I can have 2x a half, and then plus 3x squared plus 3x. So here I can see that I have 3x and 3x, therefore that will give me 6x plus 2x square root of x plus 6x squared plus square root of x, right? So if I add the like terms, here I do have a half, and then this is the same as square root of x cubed, right? Yes, so this will be square root, this is x, this square root cube plus a half x. So you can see that the half, here we do have a half, here we do have 1, because they have the like terms, therefore 1 plus a half, this is 2 over 2, that will give me 2 over 3, right? So here I can have 3 over 2, basically added these two, right? And then I can see that this one is the same as that one, not the same, but the like terms, hence I have 9x squared, and then plus 6x plus, if you add these two, that's x a half plus 1, that's the same as 2 the square root of x cubed, right? So again, here I can see these two have the like terms. If you add 2 plus a half will give me 5 over 2, and hence here I have 5 over 2 x rather cube plus 3 over 2 square root of x plus 9x squared plus 6x, right? So that in that case would be your final answer if you multiplied if you first, like, if you didn't derive this and you just multiplied this thing inside, just multiply the bracket inside, then you should get this answer here, which is what we also got when we derived using the product rule, right? So in this case, this will be my fx prime, right? Okay, so now let's look at one more example and let's call it then, right? So let's say we have fx is equal to 3x minus 2x squared times 5 plus 4x, right? Go ahead and try this on your own, and let us see. So f prime x, again here we have this function here which is g of x, right? And then we do have this function as well here which is my h of x. So we could say this one here is equal to g prime x times this part here plus that hx and then h prime x, right? So this is the function that we, or rather this is the formula that we use. So if we calculate the derivative of that is 3 plus, or rather minus, use the power rule here. I have 4x times this function here which is 5 plus 4x, and then plus the derivative of that is 4 times this function here which is 3x minus 2x squared. Okay, so if you can multiply up the bracket, then you'll notice 3 times 5, that's 15, 3 times 4, that's 12, nope, 3 times 4, that's 12x, and then minus 4 times 5, that's 20x, and then 4 times 4, that's negative 16x squared, and that times that, that's positive 12x, that and that, that's negative 6x squared. Okay, adding the like term, we have 15, we have 12x minus 20x, that is 8, minus 8 plus 12, so minus 8 plus 12, that is, come on, do the math, you get 4, right? So you get positive 4x, I'm not mistaken, so that's 24, yes, you get 24, and then negative 16x squared, negative 6, well, that is negative 24x squared. Okay, so meaning our derivative in that case is equal to negative 24x squared plus 4x and then plus 15, right? If you have gotten the answer, then congratulations to you. But yeah, so this is how we could use the product rule without having to distribute, or rather to expand the bracket and then derive thereafter. We could use the product rule to differentiate two functions that are multiplying each other. So yeah, I'll catch you on another one.